Let's look at average speed. Average speed and average rate of change are the same thing because speed is a rate of change. Think about driving a car. As you are moving along the road, you're traveling at a speed and you are changing where you are. So the speed is the rate of change, how fast you're moving when you're driving your car. So for this one, we have the position of a particle moving along a straight path is given by this function, where x is the time elapsed in minutes and f of x is measured in feet. Part A, find the average speed, so that means the average rate of change of the particle for 2 is less than or equal to x is less than or equal to 2.1. This means our interval is from 2 to 2.1. So we have a very small interval. Same process as what we looked at before. We need to figure out our f of 2. We need to figure out our f of 2.1. And then we'll calculate the slope just like we've been doing. So 3 times 2 squared minus 0.8 times 2 cubed. Let's solve it down. 2 squared is 4, times 3 is 12, 2 to the third is 8, times 0.8 is going to be 6.4. So simplifying down, we're going to get 12 minus 6.4 is 5.6. For this one, we'll have 3 times 2.1 squared minus 0.8 times 2.1 to the third. Same thing as before, we need to simplify it down so that we can figure out our f of 2.1 value. So this will give us 2.1 to the second times 3 is 13.23. 2.1 to the third times 0.8 is 7.401. Do our subtraction and we get 5.829. Now we need to calculate our slope. So we have our change in y over change in x. So the y value of our second x coordinate, so that's this one right here. So that gives us 5.829 minus the y value of our first x coordinate, so 5.6. All over our second x value, which was 2.1, minus our first x, which is 2. And if we solve it down, it looks like that will be 0.229 all over 0.1, which gives us an approximate rate of change of 2.29. Now remember, it was in feet per minute. So let's go ahead and put our units on because we were given our units. Let's look at part B. Notice all that's changed. We have an extra 0 in there. So we already have our f of 2. We just need to figure out our f of 2.01. So substitute it all in. We have 3 times 2.01 squared minus 0.8 times 2.01 cubed. And if you simplify that all down, put it into the calculator if you want, simplify it down, you'll get 5.624. So now we need to do the same thing. So we have our change in y over our change in x. So the y value of our second coordinate, that's this new one that we just figured out. 5.624 minus our 5.6 from before over 2.01 minus 2. And if we simplify that all down, we have 0.024 over 0.01, which is approximately equal. We're going to get about 2.4. And again, we need a unit, feet per minute. Notice we need the average. So we're looking for average speed. So we need 2 points. But look, they're getting closer and closer together for these 2 points. So if we were to keep getting closer and closer and closer together, what do you think would be a good estimate for our speed after 2 minutes? Well, they're going to keep getting closer and closer and closer and closer. So I think our 2.4 feet per minute estimate is pretty close. It's doing pretty good. Now, if we had gotten a negative speed, let's play what if. What if, when we were calculating this through, our speed had turned out to be negative? Well, think about when you're driving in your car. If you put the car in reverse, can you get a negative speed? No. You can get speed in the opposite direction, speed in reverse, but it will still show on your speedometer as if you were traveling whatever the speed you're going, hopefully not too fast in reverse. But you cannot have a negative speed. So if you were to get a negative for your speed calculation, that just means you're going in the negative direction, like you were going in reverse. You would want to take the absolute value and you would still report the speed as a positive value.